Anybody?
Billion. 300 million.
100 billion. 100. That's a million right there. A billion. 100 billion neurons. Do you guys know how many synapses there are per neuron on average?
10 to the 12th.
About 10,000. Let's say we'll do 10,000 synapses, and we'll say 100 billion neurons. Okay, do you guys know what the switch rate is for each neuron? Switch rate for each neuron is about 1,000 times per second that neuron fires and discharges. So each one of these neurons and each one of these synapses is having a switch rate of 1,000 times per second. The last number I want to write. You guys ever hear of microtubules? In self-phys, you've probably heard of them. Microtubules are kind of these filament structures that exist within the neurons. Now, it's hypothesized that within neurons, these can actually form as a communication system within each neuron. Individually, neurons can communicate protein structures from one end to another through the microtubules. And each neuron has, on average, 100 million microtubules. When you count all of these zeros, the number you get is 10 to the 27. And that's the processing power of your brain per second. 10 to the 27. That's a tremendous number. And it's important to understand this because you start to understand the complexity of your brain. How much is going on every single second? And how does it make you you? Today's topic is neuroplasticity. When we break it down, we understand neuro is all about the brain. The definition of plasticity is for material to undergo permanent deformation under load. Well, the load is our life. Every day we're going through our life and experiencing different things. And as we have this load, and it's malleable until it serves what we need, and it undergoes neuroplasticity. So here's a neuron. This is a balancing neuron, okay? The idea of it is it's going to help you balance, okay? Well, you're a gymnast, and you're learning how to balance. Every single day, you need to be better and better at balancing. So every day you go to the gym, you practice balancing, you activate this guy, and he's going to undergo plasticity so that he can be more efficient into the future. Neuroplasticity happens two different ways. The first one is called sprouting. Sprouting is when the neuron grows more synapses. It's actually growing more material, more arms stimulate more neurons. So maybe it goes up to 20,000. Who knows? But the idea is since you're using that one specifically, it's going to go sprouting. It's going to grow more synapses. The other one it does is called neuronal stabilization. Neuronal stabilization is when this one makes more ATP. This cell grows larger, it grows more mitochondria, it's able to produce ATP at a higher frequency, has more energy within it to use to discharge. And so it can last for longer periods of time, and overall, you're able to use this neuron more effectively because every single day you're putting load on it. That's how neuroplasticity happens. And when we look at it through this model, we understand that when you undergo neuroplastic changes within your brain, you gain mass. Your brain gets bigger because there's more cell membrane to hold more mitochondria, there's more arms sprouting off, and literally you gain mass of your brain. So the idea is, if neuroplasticity allows us to achieve new things in our life, learn new things, you're all undergoing neuroplasticity this second as we listen to this talk, we're learning new things. Our brains are constantly changing and rewiring. How do we achieve this at a higher level? Because I think if we have more neuroplasticity, our brains are capable of more, and our lives are more fulfilling. So when you listen to Dan Murphy, he talks about synaptogenesis and neuroplasticity. How do we make more synapses? And he says that there's 4 major things. You guys might want to write this down. The first one is going keto. Going keto is going to have more fats within your body, essentially, or metabolizing more fats. And so you can very simply make your body more keto by adding a tablespoon of coconut in the morning, coconut oil, tablespoon of coconut oil, and then at night you want to do 1 tablespoon of olive oil. By adding more fats into your body, you can go more keto, and you're more closer to achieving neuroplasticity, which means within the future, you can go ahead and learn things easier. The second one Murphy talks about is exercise. Exercise is important, we all know that. But when you start looking into the research behind exercise, it's directly linked to neuroplastic changes. I pulled out some studies here. Physical exercise, or aerobic exercise, enhances neurogenesis and neuroplasticity. As little as 3 hours a week of brisk walking has been shown to halt and even reverse brain atrophy that starts in people's 40s, which means as you get older, your brain is naturally going to shrink. But if you do a little bit of exercise, you're going to increase blood flow to the brain. Exercise triggers biochemical changes that spur neuroplasticity in the research. It's real. And so, that's why I beg my patients to walk a little bit. 30 minutes of walking a day will come out to 3.5 hours a week of exercise, and it's more enough to preserve the health of their brains as well as the health of every other part of their body. The fourth key to neuroplasticity within Dr. Murphy's research is going to be fish oil. Fish oil is omega-3s. Omega-3s are a fat found in the cell membrane. They're more found in the cell membranes of our neurons. So again, we're adding substrates to our body so that we can create more sprouts, more synapses with that. And so, add fish oil. I recommend about 2,000 to 3,000 milligrams a day for my patients. 2,000 to 3,000 milligrams. This is also going to reduce the oxidative damage to your brain and make it easier to achieve these neuroplastic changes. And the last one is calorie restriction. I think this is really, really interesting. Is that by fasting, about 1 day a week, you can actually trigger neuroplastic changes within your brain. I have another study. The researchers found that the rats recovered. They would give rats spinal cord injuries. And again, to recover from spinal cord injury, you need to repair the neuronal tissue through neuroplastic changes. The recovered rats that would normally be expected from the spinal cord injury gait was close to normal. They were able to cross lives, explore their surroundings in ways that the injured rats couldn't. And it's just important to see, and again in the research, that exercise is going to increase neuroplastic changes, or calorie restriction. So, in looking at all of this, it led me to this book I found called Power Up Your Brain, The Neuroscience of Enlightenment. It's written by Dr. Perlmutter, and he hypothesizes that to increase neuroplasticity, we need to release more brain-derived neurotropic factor, which is basically a hormone that stimulates neuroplasticity in the brain. He ends the book with a 5-week series that goes on. And I did this series for about 6 months ago. I followed his thing for 5 weeks. Within it, I was doing all of these, but there were other things that were added to it. Meditation. Meditation is huge, and I think Murphy missed out on this. Meditation. I have another research here I pulled up this morning. They were doing MRIs on people's brains. They had a control group and a placebo, or another group that was doing short-term meditation every day, long-term meditation, and they could find that MRI imaging was used to assess cortical thickness in 20 participants with extensive insight meditation. They found increases in the thickness of the brain cortex and the prefrontal cortex in the right anterior insula. These data provide the first structural evidence for experiment-dependent cortical plasticity associated with meditation practice. And we've proven this through MRI now, that meditation makes you smarter, makes your brain bigger, physically bigger. I think this is interesting because this book was co-written with a shaman. Shamans achieved enlightenment, and I've talked about enlightenment as optimal brain function. It's interesting that in ancient shamanic practices, they were already doing meditation. And we've only now proven in 2014 that it really is increasing neuroplasticity within people. The fast also covered diet changes. You were able to avoid things that would inflame you or irritate the system. Those, again, are going to cause more oxidative damage and make it harder for you to release the BDNF, the brain-derived neurotrophic factor. So all of these are taking away from plastic changes. The way I really want to end this talk is when we think about neuroplasticity as us growing into our environment, becoming more capable people. Don't we see that with chiropractic every single day? What we expect of neuroplastic changes already happen in people under adjustment. And it's my hypothesis that chiropractic is going to be the sixth one. If we could prove that, how would it change the world? If we could prove that people's brains could literally grow from being adjusted, and I confidently believe it is, who would we reach? How could we become the better versions of ourselves? I think all of these here can be used well in conjunction with chiropractic, because they're all trying to achieve the same thing. It's going to be an optimally performing brain, nervous system capable of growth into the future. The things that life is going to give us, and be able to grab that, cope with it, and adapt to it so it's better in the future.